Okay, so last time we talked about groups. Let's talk a little bit more about specific terminology again within the groups. So let's consider this molecule again. Let's say this square planar complex. And then we have our 4 different chlorine atoms, A, B, C, and D. So let's think about the elements that are the symmetry operations that we have. So we have E, we have C4. Again, so this is down this axis into the board. If we do C4 twice, we have C2 down that axis. And if we do C4 3 times, we have C4 3. So those are all down this axis. We have, let's see, one perpendicular C2 going this way. So we'll call this C2 prime because this is perpendicular to our central axis. We have another C2 prime over here, so this way. So we have C2 prime, I'll call this C2 prime A and C2 prime B, and then C2 prime B. We have 2 more C2s this way. So we'll call this C2 prime prime A, and this will be C2 prime prime B. C2 prime prime A, C2 prime prime B. Okay, mirror planes. We have one mirror plane. I'll do mirror planes in yellow. Not that you can tell yellow from green, but so here's a mirror plane in the board. So this is perpendicular to our C4, which is down going into the board as opposed to in the board. So here's my mirror plane. Here's my axis. So we have this is our sigma H. So we have a sigma H. And then we have, let's see, going into the board, along these axes with the bonds, we have sigma V. Let's call this sigma V A. And then here we have another sigma V B. So again, these are along the bonds. A, sigma V B. And then going between the bonds, we also have a mirror plane because we can mirror the chlorines onto each other. So here we have, let's call this sigma D. So this is a dihedral, again, between the bonds. So this is sigma dA, and we'll call this sigma dB. A lot of subscripts. A, sigma, oh sorry, sigma dB. What other symmetry elements do we have? Oh, we also have inversion. If we invert D onto B, C onto A, platinum stays in the same spot, we have inversion. Oh, and then we also have S4. S4 twice is just a C2, so we're not going to worry about that. And then we have S4 3. Is that all of them? As far as I can tell, that's all of them. I may be wrong. Let me know. So these are all our symmetry elements that I could think of so far. So the definition of classes, which is what we're talking about today. Classes are a subset of elements within the group of elements that are so-called conjugate to each other. And this is useful because what this means is that we can group some of these elements together in the same class later on when we're using things like character tables, which we'll be talking about in a little bit. So how do we figure out which elements are conjugate? You can sort of do it by inspection. So you can see that C4 is qualitatively the same as C4 cubed, because you rotate 90 degrees and then you rotate negative 90 degrees. That's not very satisfying. So the strict definition of elements are conjugate to each other. So A is conjugate to B. These are 2 elements within a group. To B if A equals the reciprocal of X, which is any element in the group, times B times X. So this is another element. Any other element in group. Note that X does not have to be conjugate to A or B for this to hold. It's any element, and you take the reciprocal and the non-reciprocal and multiply this out, And then if A is this product, then A is conjugate to B. Sometimes I'll point out when you do this product, you get B back, and that's because every element is conjugate to itself. So you didn't do anything wrong, you're just kind of incomplete. So for this example, let's consider, I said something like, what happens if we look at C4? So let's say that B equals C4. And let's just try taking, so C4 is, let's say we're going clockwise down this axis. And then let's say we do, for example, sigma VA on it. So let's say x equals sigma VA, and then which means that I said the mirror plane reciprocal is also the same mirror plane. So reciprocal of x is going to be sigma VA as well. So let's start. So we have platinum, chloride, 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 chloride. So A, B, C, D. So if our first operation is going to be x, sigma VA, so this is x. And sigma VA, if you remember, is along this axis. So what we'll get out is, I'll just write the labels. So we mirror plane along going into the board, and then we'll still get B, D, these are unmoved, but C and A will flip, so we'll get to A and C. And then our next step is to then multiply B. Remember, we're going right to left. So now we'll do the C4. And this will give us, so rotate counterclockwise. We will get B, C, D, A. And lastly, we'll do our x reciprocal, which is going to be sigma VA. And keep in mind, the symmetry operations themselves don't move, so we still do sigma VA along here. And then so our final orientation, A and C stay in the same spot because they're along this mirror plane. B and D will flip. So we'll get out D, B, A, C. So now, to figure out the product, we want to figure out what operation gets us to here from our starting orientation. So we can see that A has moved to the right, D has moved to the right, C has moved to the right, and B has moved to the right, or I guess moved clockwise. So this is the same thing as if we did a C4-3. So the similarity transform, so this is called the similarity transform. Similarity transform. So what this means is that C4-3 equals sigma VA C4 sigma VA. So therefore, C4-3, C4 are conjugate. And they are in the same class. So to find all the elements are in the same class together, you have to kind of play around a little bit more, try a bunch of different elements. Because this does not mean that this class is complete. We found all the elements from here that are conjugate to each other. All we found out is that these two are conjugate. If you play around, you might get that C4 is conjugate to itself, or C4-3 is conjugate to itself. It might be incomplete. So all this tells you is that these two are the same. I will point out, though, in this case, these two are the only ones that are conjugate to each other, so they're the only ones in the same class. But this is, again, not always the case. For this particular example, I'll point just like, so these C2 primes are in the same class. These C2 primes are in the same class. C2 along this axis is by itself. Let's see, sigma VA, sigma VB are together, sigma Ds are together, and the S's are together. So if you want on your own, you can try the similarity transform and prove those to yourself.